Hey, hello guys, welcome to my channel Code with Anish. Today we will learn how to deploy a Springboot web application in Kubernetes cluster. In this section, we will create a sample Springboot web application first, then we will create a Docker image of this web application and publish this Docker image into the Docker Hub. Then we will create a Kubernetes cluster in AWS, which is Amazon Web Service. After creating the Kubernetes cluster, we will deploy this web application in this Kubernetes cluster, and then we will check whether this application is accessible over the internet. Fine. So we will first create the Spring Boot application. I am using IntelliJ IDEA for creating my Spring Boot application. So here we can first click the new project button. So here we can give the name as Spring Boot Web K8s, which means Kubernetes. So Spring Boot Web Kubernetes, that will be my project name. I will be using Java 17 as the JDK, and now in the advanced setting I can give my group ID, which I give org.anish, and the artifact, let it be the same name of the project. Okay, and we'll click the create button. Okay, so it has created the project with a default main class here. We may not want this, so we can delete this thing. Let the main method be there, the content inside we can delete it. Okay, that's all. So we have the form.xml also here. Now we need to change this form.xml to adapt to the Spring Boot application. So we need for Spring Boot application, so we have to add the appropriate dependency. So first we need to add the parent dependency. So parent is here, and we need to add the artifact ID, the group ID, and the version. Okay, so the group ID, it's org dot spring framework dot boot, and the artifact ID should be spring starter parent. The version, we can use some latest version of Spring Boot 2, so we'll go with 2.7.8. So that is the parent form. Now we have to provide the other dependencies, so we will add the dependencies section, and here we will have the dependencies. So in the dependency, again the group ID same we can give, and since we are creating a Spring Boot web application, we need to add the starter web as artifact. So Spring Boot starter web is here. So that's also here on small typo. Okay, so we have added the dependencies also. So this is pretty enough for our application, and to build this application we need the plugin. Build plugin. So here also we need the group ID, again the same, or dot spring framework dot boot, and the artifact ID is Spring Boot Maven plugin. So this is required when we build our application. To create an executable jar, we need this plugin. So that's all. We can reload this POM file so that all the dependency library will be downloaded. So we'll click this button. Okay, yeah, if we see here in the extend library, we got all the Spring libraries which we required for creating the application. So that's about the POM dependency. Now we'll come to the main application. The main class has to be annotated with the annotation Spring Boot application. And inside the main method, we have to call spring application dot run, and the class should be this main class. So class should be this main class, and the arguments to this method is same as what we got from the main method. And now for a web application in Spring, we need some controller classes. So the controller is nothing which is the endpoint, where whenever we call an URL, this is the endpoint where the URL comes and hit. So we need to create the controller. So for that, we'll come here. I'll create a package here with name ending as controller. So I created a package, and now we'll create a controller class. So here I will just name as a hello controller. So that's the class. And since we are going with the REST web service, so REST web service, we use a REST framework, which is basically supports the uh, create, update, get, and delete HTTP methods. So I'll give the REST controller here, and I'll give the request mapping. At request mapping, I'll give us hello. So which means when this web application is called with an URL, an URL ending with slash hello will be directed to this class. So that's what does this request mapping means. So now I will create another method which need to handle the request. So I'll create public uh, and give a string as response. I will give the name the method as hello, and here I will annotate with a get mapping, which means the URL hello with the HTTP method get will be pointed to this method. So here I will just return a string saying that hello. So that's all. So whenever an URL is called with the get method with this hello ending with hello, then I am expecting a response as a hello. Now we need to build this application to create a jar file. So to build this application, we have to use the Maven commands. So this Maven commands can be run from IntelliJ by using the configuration. So to run that, we have to go here, click this drop down and click the edit configuration. And we have to click this plus button. So it will show the list of configuration option. So from here, we have to select the Maven. So we have to give the Maven commands here to do the build. So basically we need to give the clean command so that it will clean existing jars if any, or the target folder, and then we will give the command as package. So the package command will build this and will create a jar file. So basically it is the packaging of that application. And now we click the apply and OK. Now we can click this play button to start the build. Okay, so the build has started, and yep, it's finished successfully. So you can see a target folder being generated, and inside the target folder you can see the jar file which was created after the build. So jar file contain the project name as well as the version. So the version, all these are specific to POM file. So here if you see the project name or the artifact name is given as Springboot Web K8, K8s, and the version name is 1.0 snapshot. So if you want to change this name of the jar while building, we can do it by adding a final name parameter inside the build. So here we can give a final name, and so I don't want the version, I just only want the artifact name or my project name. So I can give only that here. Okay. So now if I try to click this play button again, so it will do the clean first. So clean will delete all the existing jars generated. Yeah, and the package will again rebuild and create the jar file. So now if you can see, the jar file created only with my artifact name or the final name which I've given here. Okay, so now the jar is ready. So now the next step is we have to create a Docker image of this jar, which or a Docker image containing this jar, I will say like that, and then we need to publish this. So before starting that creation of Docker image, uh, let me give an heads up about Docker. So what is Docker? So Docker is basically an open platform which help us to separate our application from the infrastructure, so that we can deliver our software without worrying much about the infrastructure. That means the Docker provides the ability to package and run the application in a loosely isolated environment, which is called the container. Okay, so what does that mean? So earlier, before this Docker was there in the picture, earlier how our application or the deployment of application we do. So in this case, we used to deploy this jar in a server or an environment. So assume uh, here if you see, we build this jar using Java 17. So we use Java 17. So whenever we deploy this jar in a server or in another environment, we should make sure that that environment also should support Java 17, should contain the Java runtime 17 there. Because if instead of Java 17, if that environment contains Java 11 or Java 8, this application will fail there. So that means the deployment team should make sure this thing, this application when we are deploying there, it should contain Java 17. Same way, if this application is listening to some port, yeah, obviously this is a web application, the Spring Web application default port is 8080. So this obviously will listen the port 8080. So they should open that port in that server also. Then only this application can be called from outside. So these all are the infrastructure, like the making sure the runtime, making sure the ports are open. So uh, this kind of thing will be like a manual changes or the manual intervention is required whenever we deploy this application. So with the Docker coming into picture, we are no more deploying our library or jar to the server like we did earlier. Rather, we create an image or a Docker image, so which contain all these required infra changes like this Java runtime version, the ports to be opened, and etc. So now let me show how we can create a Docker image. So in Windows machine, to run the Docker, to create the Docker image, we have a tool called Docker Desktop. So we can open that tool. Yeah. So here, if you see the Docker engine, it is saying the Docker engine is already running. If it is not running, you can click the play button here so that the Docker will be started. So this application you can download from the Docker official website itself. You can just go there and just download for the Windows machine. Once after downloading it will, you can install it and you can see the console like this. So here if you see, it's saying as container, images, volumes, blah blah blah. So as I was telling earlier, the container. So here, so container, what was a container? Container is a environment. It's a loosely isolated environment where we can deploy our images uh, and run there and run that application there. So to create an image, we need a file named as Docker file. So Docker file is nothing. It consists of some commands which is required to create an image. So we can create a Docker file in this project. So we will click new file and Docker file. Okay. So inside this Docker file, we have to give the commands. So I am giving the first command as from Eclipse Tamarin 17 JRE Alpine. So what does from command means? It downloads this image, this pre-existing image. So this is an already existing image in the Docker for the Java runtime 17. So by giving us from and that specified image, what it really does is it will download this image to that container. So next command, add target and our jar file name Springboot web k8s dot jar, and we give the same name there as well. Okay, so this command says that when you are building that image, you just copy the jar file which is in our local folder, which is where. So we are running the Docker build command in this folder, in the root folder, in the root of Spring Boot Web K8s project folder. So when we run that, it is saying copy the jar from this target folder, copy this jar and keep that jar as the exact name inside the container. So that is what does this command mean. Expose 8080. So as the name itself says, it expose means we just want to open this port 8080. The Spring Boot application will always listen the default port 8080. So that's only. So what does, so this command says that in the container, please expose this 8 or please open this port 8080 so that others can, from the external we can connect to this port. Now the final comment. Yeah. So final command is the entry point, which says that once this image is deployed in the container or installed in the container, this is the command which should run inside the container. So command will be given as a comma separated variables. So here what does this mean is it is it is equivalent to running like this java minus jar spring boot. So this is something in our old in any system where we want to run a jar file, we give java minus jar and the jar file. So with this command in this docker file, it means that once the image is deployed in the container, please run this command at the this command to start the application. So this command will be run java minus jar so that the application will start in that container. Need a space between there. So that's all for the docker file. So now we can build this docker file. The command to build the docker image is docker build minus t, a namespace. So here the namespace I am using is code with Anish 1988 slash repo name for the image. So we can give the same project name as the repo name. Then a version name. So the version name I will just give us latest. You can specify as version 1, 2 and all, so I'm just giving us latest. Then a dot command. So this command will build an image as specified in the Docker file here, with the namespace this and the repository name this and the version as latest. So just let's run this command. Okay, so you can see the Docker build is successful and the image has been created. So to see the image, we can open this Docker desktop tool, and if you come to the image, we can see, yeah, so this image has been created successfully. Now we have to publish this image to the Docker Hub. So we need an account in the Docker Hub. So if you come here, this is my account in the Docker Hub. So here you can see the namespace. So the same namespace should be used. That's only I use the same code with Anish 90. Then only when we try to push this image, it will check for this namespace, and under this namespace, it will create this repository in the Docker Hub. So pushing, we can, from here we can use this command, or even from the terminal also we can push it. Docker push, again the same namespace, tag name, and the tag, the version name or the tag name. Okay, so it has been pushed successfully. We can go to the hub and check if it has came there or not. So you click the repository here, refresh the page. Yes, so our image has been pushed to the Docker Hub successfully. Yeah. Now we can test this image. So you can see here, right? So now we have the image here. So we will not see any container here. So we will test by deploying this image in a container and see if it is working or not. So the command to deploy this application is docker run, again the same namespace, I mean the I will say as image name, this full containing the namespace, repository name and the tag name. Paste docker run. We will also give one parameter minus p 8080. So this parameter is mainly for the port forwarding. So as we see in the docker command, this image will be or this application will be listening in the docker container in the port 8080. So in order to forward our localhost 8080 to the docker container port, we use this parameter. So minus p 8080 means localhost 8080 should be mapped to the container port 8080, so that from our local host we can connect to the container. So we will run this. Okay, so it has successfully deployed and the Springboot application has also started. Now we can see in the Docker desktop whether a container has created or not. Yeah, so you can see here a container has got created and the port forward is 8080. So that's all you can see from the localhost 8080. If we connect, it will connect to the 8080 in this container. This container is again another instance where the application is running now. So let's see in our browser whether we are able to access this URL. So open here, localhost 8080, and we just first will give localhost 8080. Okay, the page is opening, but there is an error which is saying not found. Why? Because in our application, we have created only one controller to handle the target slash hello. So there is no other controller to handle any other request. So here this is a root, uh, what is a root URL. So the root URL is not just handled here. That's only we are getting error. So now if we give hello, we expect it should return a response as hello. Let's see if it is working or not. Yes. So we are seeing this response here. So that means our application is running fine, and it is deployed successfully in the Docker container also. So that's all for this video. In the next video, I will show you how to deploy this application, this containerized application in the Kubernetes cluster in AWS, in Amazon Web Service. Thank you.